Good morning, good evening, good afternoon. Today's topic is Compton Scattering. The last video we discussed about Thomson scattering and how it proved light as a wave, but it has some limitations as well. It fails to give accurate measurements, accurate calculations when we have high energy photon instead of a low one. Compton scattering is when a high energy ray, X-rays, gamma rays, when they collide an electron and then bounces off, they lose some energy and the wavelength of the photon increases. So this overall proves that light is a particle rather than a wave. Let's say this is the photon. Since we assume it as a particle, this will have some energy, some momentum. Assume that this photon is on its way here, hitting an electron. Collision occurred here. Then let's say the electron moves downward and the photon moves upward. Now we have here gamma prime. I'm not using gamma because after the collision, the frequency, the wavelength of the photon changes. Initial wavelength is always smaller than the final wavelength. This right here is the change in wavelength. Here the theta is the scattering angle of the light. This part is known as the Compton wavelength of an electron. What if the scattering angle is 0 degree? So we say theta is equal to 0 degree. Now cos 0 degree is 1, so this would become 0, and then this entire thing would become 0. Total change is equal to 0. Initial wavelength is equal to the final wavelength. The electron didn't even move, it did not shake, it did not move when the scattering angle is 180 degree, and this is known as backscattering. Then we can say that fixing the angle with cos pi, that is the same thing as cos 180, and cos 180 is minus 1, so it becomes 2. The maximum wavelength we get when theta is equal to 180 degrees. This would be 4.86 into 10 to the power minus 12 meters. And when theta is 90 degree, so we say that this cos 90 is 0, so this would be 1. Then the total change in wavelength would be equal to the Compton wavelength of the electron. That's it for today's video. Thanks for watching.